Okay, this video is about complex conjugates, which are essentially opposites. So a plus bi and a minus bi. So for example, 4 plus 2i, the complex conjugate would be 4 minus 2i. If the first number were negative, negative 3 plus 7i, it stays negative, negative 3 minus 7i. If there's no real term at all and it's just 8i, well then the complex conjugate is minus 8i. Something really cool happens when you multiply complex conjugates. When you multiply complex conjugates, the imaginary part goes away. Here's an example. If I were to multiply 3 plus 7i, well, let's think, what's its conjugate? All I'm doing is changing this sign, so 3 minus 7i. If I FOIL this, I have 3 times 3 and 3 times negative 7i, so that's 9 minus 21i, like that. And then I have plus 21i, and then 7 times negative 7 is minus 49i squared. Next up, you can see my two middle terms, negative 21i and plus 21i. These two terms cancel because they make 0. So what I'm left with is 9, take away 49i squared. And there's one more thing you can do. I squared is equal to negative 1. So what I'm going to do is, instead of having I squared, I'm going to substitute in the negative 1. And you remember that's because I is equal to negative 1. So if you square it, that goes away and you just have negative 1. So what this turns into is 9 take away 49 times negative 1, which is the same thing as 9 plus 49, which is equal to 58. The other way you can do this, if you want to kind of do a shortcut, is that you could use this formula, which says that a plus bi times a minus bi. Think of this as a difference of squares. So really, what we have here is this squared minus bi squared, which is a squared minus b squared I squared, but we know that I squared is negative 1. So a squared minus b squared times negative 1 is a squared plus b squared. So that's actually what we got over here, because if you think about it, a is equal to 3. So a squared plus b squared would be 3 squared plus 7 squared is 49. So 9 plus 49 also gets you your answer. That's kind of a shortcut way to do it.